We can understand the solution that we've arrived at algebraically also using the following geometric or graphical argument. We've drawn here the curve that represents the predation rate of the aphids by the ladybugs. Let's also superimpose on the same graph the growth rate, which is simply a linear function, a straight line that goes through the origin with slope r. We find that there are 3 intersections. One is at x equals 0, and the 2 others are solutions of the quadratic equation. We've shown earlier that these solutions only exist provided that k over 2 is bigger than r times a. Now observe that r times a, that's precisely the point sitting on this graph corresponding to the value of x, the aphid density a. And we see that in the configuration that we've drawn here, k over 2 sits higher than the y value of that blue point. Now suppose we look at what happens when the growth rate of the aphids is higher. That means the slope of this blue line will be larger. Here we've drawn a growth rate with a higher slope, namely a larger r value. And observe that now when we look at the point on the line corresponding to aphid density x, we get the point RA, which sits up here. And indeed, that level is higher than k over 2. And in fact, the 2 graphs no longer intersect. In other words, there are no longer solutions such that the growth and the predation rates of the aphids are precisely balanced. And so we can understand this inequality as telling us something about the configuration of these 2 curves in the plane.